Hey students, in this video we're going to cover lesson 2 for conic sections, and that is ellipses. So let's get started. In our previous lesson we talked about circles, and a circle was a set of points that were a fixed distance from one point that we called the center. When we talk about an ellipse, it has that same property, except the points are the same total distance from two fixed points that we're going to call foci. So if you see in our diagram, we have F1 and we have F2, then on the ellipse, whatever this distance from F1 to XY is, plus F2, plus the distance back to F2, if we put another point here, we'll call this point x2, y2. Then this distance that these two other green lines that I'm drawing, so we'll call this D3 and D4. What's true about an ellipse is that D3 plus D4, which again, just two distances, is going to be equal to whatever D1 plus D2 equals. And that's the property of an ellipse. All of the points are the same total distance away from two fixed points inside of the ellipse, and those points are called foci. So that's what we're doing when we have the equation for an ellipse. And again, D1 plus D2 is the same distance for all points on the ellipse. So unlike a circle, ellipses are the foci, they're not in the center of the shape, but they're on the major axis of the ellipse. And the major axis is just the longer axis, and both the major and minor axes go through the center. So in this case, in our diagram, we can see that the major axis is the horizontal axis, and so our foci are on the horizontal axis. And then we have this minor axis that runs through the center vertically. So an ellipse has 4 points called vertices. The vertices are just the endpoints of the major and minor axis. So we always have 4. We have V1 and V2 labeled, but we could also put here, this is our V3, and that point could be our 4th vertex, V4. And the distance from here to here is, we'll call it like the major radius, just for lack of a better term, is going to be, we'll see this in our formula, and we have another value that's going to be different. Like say this value is A, then this value here is going to be a B value. And they're different numbers. If they're the same number, we have a circle, but ellipses have two different, we'll say radii or radiuses, if you will. So we're not going to go into the derivation of the formula for an ellipse. It's somewhat complicated, so we're just going to look at the general form. So it's x minus h squared divided by a squared plus y minus k squared divided by b squared equals 1. And just like a circle, the center is hk. And there are two things that happen for the foci. If A is bigger than B, that means your major axis is your horizontal axis, and your two foci are on your horizontal line. If B's larger than A, your two foci are on your vertical axis, and that's your major axis. So if we go back and look at this again, now A is just, in this case, A is larger than B, so the X is going to be your major axis, and so the distance from the vertex to the center, that's this A value. And the distance from the center to the vertical vertex points, that's your B value. And again, that's going to be the square roots of whatever numbers you have in your denominator. In either case, when you're finding C, your foci, C is just going to be the square root of the larger denominator minus the smaller denominator. And again, make sure you're putting in the square root of this number, not the number that is in the denominator. So we'll see that as we get started. All right, so for number 1, we have to draw an ellipse from this equation. We're also going to graph the foci. So when we write this, let's rewrite this as, let me move this cursor because it's blinking. Let's move this out of the way. Move it over here. All right, so let's rewrite this in a form that we'll see. So we're going to have x plus 5 squared divided by 4 squared plus y minus 4 squared divided by 1 squared, and that's going to equal 1. So in this case, now a is always the number with the x, b is always the number with the y. So here we see that a is going to equal 4 and b equals 1. So obviously a is greater than b. And so our major axis is our horizontal axis. The center for our ellipse is -5, +4. So let's write that. We're going to put the center is -5, +4. So let's see, we get -1, 2, 3, 4, 5, +1, 2, 3, 4. So this is our center right here. And then, so from here, we're going to go right 4 and left 4 for our major axis. So we're going to go 1, 2, 3, 4. This is one of our vertex points. And then we go to the left from the center. We're going to go 1, 2, 3, 4. And we have our other vertex for our major axis. So we have our V1 and our V2. And then for the vertical axis, we're just going to go up 1 because b equals 1. So we go up 1. It'll let me draw the dot. All right, smart boy is not acting right. So we go up 1, go down 1, and then we try to draw a smooth enough ellipse. It looks something like that. All right, so that's our ellipse. I can't really draw. Don't judge me. Our foci. So now our foci are going to be, so we need to find C. So C is going to equal the square root of 4 minus 1, which equals the square root of 3. And so from the center, all right, so we're going to say this, what is the square root of 3? It's like 1.7 something or another. Let's see. The square root of 3. Hold on a moment. Square root of 3. Yeah, 1.73. So C is equal to 1.73. So from the center, we need to go, so our center is -5, right? So foci 1 is going to be -5 plus C, and that's going to be -5 plus C4, and the other one is going to be -5 minus C4. Now, obviously, we can substitute those numbers in, and we get, let's see, -5 plus 1.73 is -3.27. So -3.274, and -5 minus is -6.73, duh. So -6.734. So if we're going to plot our foci, we say like 1 is here. So we'll say that's our F1. And then -3.27 is about like right here. Now again, for the foci, unless you get a perfect square, that's going to be pretty hard to come up with. So as we plot them, so we get F1 and F2, and that's it. So we graphed our ellipse, we plotted our foci, and that's all we need to do. All right, so now we did that with the equation. So for example 2, we're going to write our own equation given some information. So for number 2, we have the center of the ellipse is 3, 6. So let's go over 3 up 6. So the center of the ellipse is 3, 6. The vertex, one of the vertex points is 3, 1. So we'll put that here. So that's going to be our V1. And the focus, one of the focus points is 3, 2. So if I can make this dot. So, and we'll call this our focus point 1, and that's our center. Now, because our focus is in line vertically with the center, we know our vertical axis is the major axis. So the vertical axis is the major axis. Cool. And so now, to get the length of the major axis, well, from the center to the vertex, all we have to do is count. So we go down 1, 2, 3, 4, 5. So we know B is equal to 5. So B is equal to 5. And C, I'm sorry, you know what? Let's use a different point for this. Let's just call, instead of writing C for center, let's write the entire word. So we don't confuse that with C from our foci. So C is the distance from the foci to the center. So our C value is 4. Now remember we said that C is equal to the square root of the larger denominator minus the smaller. So in this case, C is going to equal the square root of B minus A. Okay, so now if we know that, then we know 4 is going to equal, because C is our 4 is C, so C is going to equal the square root of B, which is 5, minus A. So now we need to square both sides, and that's going to give us a square 16. I'm sorry, this should be b squared minus a squared. My apologies. So that should be b squared minus a squared. So 5 squared minus a squared. So we're going to get 16 equals the square root of, well, no square root anymore. So 25 minus a squared. Again, we just squared both sides to get rid of the square root. And so now to solve for a, we subtract 25. So we get negative 9 equals negative a squared. That's the same as saying positive a squared equals 9. And so a is obviously going to equal 3. So now b equals 5, c equals 4, and a equals 3. So a equals 3. So from the center, now we can erase this. We're going to go right 3. If we wanted to draw this, we're going to go right 3, and we're going to go left 3. So we end up here. And then from the center, we can also go up 5. So 1, 2, 3, 4, 5. And if we draw our ellipse, we would get something like that. Now again, Mr. Martin can't draw, but that's it. So now we have enough information to write our equation. It's going to be x minus 3 squared divided by a squared, which is going to be 9, plus y minus 6 squared divided by b squared, which is going to be 25, and that's going to equal 1. So all of that we used to write our equation, and we also drew the ellipse because we had the graph. For example 3, we're given just the foci and the vertex. So now the foci are plus and minus 0 plus and minus 5. So we're going to go up 0, go right 0, go up 5. We're going to go down 5. And so now clearly our center is going to be here. So this is our center, clearly. So our center is there. Our vertex points to 0 plus and minus 8. So we'll put V1 up here, and we're going to put V2 down here. So now again, our vertical axis is our major axis. So if we count from the center to one of the vertex points, that's going to tell us that B equals 8. And we know that our C value is the distance from one of the focus points to the center. So we have our focus point 1, we have our focus point 2. So if we count from the center to the focus, that's clearly going to be 5. And again, C is just going to equal the square root of the larger denominator. So in this case, it's going to be b squared minus a squared. So we know 5 is equal to the square root of 64 minus a squared. So if we square both sides, we get 25 is equal to 64 minus a squared. This will give us a squared equals 39. And so a is going to equal the square root of 39, which is about probably like 6.3 something. 39 to the 0.5, 6.24. All right, so it's close enough to 6.25. So we'll say 6.25. All right, so now we know a is equal to the square root of 39, but it's also 6.29 if we want. So now we can write our equation. Let's see. So we're going to have, our center. Now our center is just the midpoint of our foci. So the center is just the midpoint of the foci. So one focus point has a coordinate of 0, 5. The other one has a coordinate of 0, negative 5. So the center, we'll just do this appropriately. The center is the midpoint of that. So it's 0 plus 0 divided by 2, comma, negative 5 plus 5 divided by 2, which turns out to, again, of course, be 0, 0. So that's the center. But you just do the midpoint from the foci or the midpoint from the two vertex values if you have those, and that gets you the center. So we're going to have x minus 0 squared divided by a squared, which is going to be 39, plus y minus 0 squared divided by b squared, which is going to be 64, and that equals 1. All right, so that is what we do if we're given the foci and the vertex. Next, we're given just the vertices, and we're given the two vertices and the endpoints of the minor axis. Now, if you don't have a graph, you can just make a small sketch. So one of the vertex points is this is the point 3, 2. And so just straight over, we can have if this smart boy is not cooperating. So then we have another vertex point of 13. We'll say that's V2. This is our V1. So now I told you that if you have the two vertex points, the center is the midpoint of the two vertex points. So our center is going to be, 3 plus 13 divided by 2 and 2 plus 2 divided by 2. So that's 16 divided by 2, which is 8, and 4 divided by 2, which is 2. So the center is 8, 2. And then the endpoints of the minor axis are 8, 4, and 8, 0. So let's put our center here. And so we know that has coordinates of 8, 2. And so now if we go up from here, we're going to go 8, 4, and then we go down 2 from here. We're going to go 8, 0. All right, so now what that tells us is that the horizontal axis is the major axis. And then from there, we know that we know B is equal to 2. And we know A is equal to the distance from one vertex point to the center. So A is going to equal 5. So the equation for this ellipse is going to be, x minus 8 squared divided by 25 plus y minus 2 squared. So y minus 2 squared divided by b squared, which is 4, and that equals 1. Now, if we wanted to, we could say that our foci, so let's see, c is going to equal the square root of, c is going to equal the square root of 5 squared minus 2 squared, which is like the square root of 21. So that's going to be, I don't know, like 4 point something or another. So we'll just say our foci are 8 plus the square root of 21, 2, and 8 minus the square root of 21, comma 2. And that's all we need. But this is the equation that we get from that. And so lastly is completing the square. This is a good problem to complete the square for. So we have, we're going to complete the square to find the equation of the ellipse and write down all of the relevant information about the ellipse. So first, let's organize our terms. So we're going to have 9x squared minus 54x plus 25y squared minus 50y, and we're going to move that 119 to the other side. Okay, and so now when we complete the square, we're going to factor out a 9 from the x terms, and we're going to factor out a 25 from the y terms. So that's going to give us 9 times x squared minus 6x. So if we complete the square with the negative 6, then half of negative 6 is equal to negative 3, and negative 3 squared is equal to 9. So we're going to add 9 here, but remember on the other side of the equation, you also have to add that value. But first, so we added 9 inside the parentheses. When we multiply that by 9, we've really added 81 to both sides of our equation. So right now, that's going to total up to 200. And then we also have, for the y, we took out 25, so we get plus 25 times y squared minus 2y. And so then we also have, for the y's, we have half of negative 2 is equal to negative 1. Negative 1 squared is equal to 1. So we're going to do plus 1. But what we've really added to the equation is 25 times 1. So we're going to add 25 on the right side as well. So total, that equals 225. Okay, so now we get 9 times x minus 3 squared plus 25 times y minus 1 squared equals 225. Now what's different about ellipses instead of a circle is that we now need to divide everything by 225. So we're going to divide this by 225. We're going to divide that value by 225. And we're going to divide that value by 225. And so 9 divided by 225 is going to simplify to be 25, and then plus 25 divided by 225 conveniently is going to simplify to be 9. So x minus 3 squared divided by 25 plus y minus 1 squared divided by 9 equals 1. So from there, the information that we know is that the center is 3, 1. The center is 3, 1. The major axis is our horizontal axis. So that's going to tell us that A equals 5 and B is equal to 3. And then for our foci, we can find C. So C is going to equal the square root of the larger denominator, so 25 minus 9, and that's going to give us 4. So for our foci, since the horizontal axis is the major axis, one of our foci points is 3 plus 4, comma 1, and the other one is 3 minus 4, 1. Now, of course, that simplifies to be 7, 1, and negative 1, 1. All right, so that concludes our video for ellipses. I do think I want to go back to number 1 because I think I made a small mistake in the problem. in number one, when we were finding the foci, this should have been the square root of 16 minus 1, which is going to be the square root of 15, which is still 3 point something, but it's the square of the denominators subtracted. So let's clean that up. Square root of 15 is 3.9. So instead of our foci being here, that's going to be, let's change this around. That's negative 5 plus 3.9, which is negative 1.14 and negative 8.94. So negative 8.9 is going to be like right here, and negative 1.1 is right there. Well, it's like right there. So those points should be right there instead. All right, so now that concludes our video on ellipses. Hope to see you all in class.